Good day to all. Welcome to the webinar, BIM in Infrastructure, the Essential Steps and Key Turns. People are still coming in, so I suggest that we wait a couple of moments more before we start with the webinar. Okay, I suggest that we start with the webinar now. My name is Gregor, and together with my colleague Petra, we're really excited to host you today, and we hope you will enjoy our company as well. First, let me share with you short technical information about the webinar. So the session is being recorded, and it will be shared with you later on. And you're welcome to ask questions during the webinar. And for this purpose, you can find a section in the webinar dashboard. Please type your questions there, and we will try to answer them at the end of the webinar so that we don't disrupt the flow of the webinar itself. So we're really happy to see many of you who we meet actually for the very first time. So let me take the opportunity to very shortly present our company. CGS Labs is a software company that has been engaged in the digitalization of the built environment since its very inception. And we have over 30 years of experience in this field, and CGS Labs has developed specialized software to support civil engineering design. And today we'll be sharing some of our experience, particularly in the field of BIM. CGS Labs is an international software company, so we have offices in Germany, Czech Republic, Serbia, Slovenia, but we also have a worldwide network of partners. And actually our software solutions, we can say, are used on all continents around the world. We're also an active member of the international organization Building Smart, and we contribute to creating and adopting Open BIM international standards and solutions for infrastructure. Our company also provides Building Smart education and professional certification for engineers. And we can say that as a software developer, we strongly advocate the Open BIM and standardized IFC data exchange, which you will find out more in this particular today's webinar. Maybe some more information for those who are not yet familiar with the organization Building Smart International. It is actually a non-profit and independent international organization which is dedicated to the development of Open BIM standards and for the digitalization of the built environment. These Open BIM standards enable efficient collaboration and exchange of digital information and can contribute to support the circular economy, green transition, and also decarbonization. If we look quickly our portfolio of software, we provide solutions for three main civil engineering fields. This is road design, railway design, and river engineering design. And our software can be used for all stages, for preliminary designs, detailed infrastructure design, and creation of detailed 3D and BIM models, as well as the project documentation. And now, without further ado, I would hand the floor to my colleague Petra, who will guide you through the process that actually designer goes through in a BIM project. She will use a practical example of road reconstruction project to illustrate the process. Please, Petra, the floor is yours.
Okay. Just a second. Okay, thank you, Gregor, for this introduction, and hello to everyone. So I hope you are all having a great day. My name is Petra, and I work as a technical support engineer at CGS Labs. So thanks for joining us for today's webinar. I'm super excited to see so many participants. So let's spice things up and make this session even more interesting and fun. So on this Go to Stage webinar platform, you can find a chat tab. So please write down the country you are joining us from to see how far our audience reaches. So according to the application data, there should be participants from more than 50 countries. Okay, so all right, while some of you kindly share your location with us, we will slowly transition into the main webinar. So in today's presentation, I will explain what road and railway designers need to pay attention to when they start working on a BIM project. So we will take a practical look at the basic steps, tools, and benefits that come with using BIM. So additionally, you will become familiar with some important terms like BIM Execution Plan, common data environment, industry foundation classes, and BIM collaboration format. Since the data is a key part of BIM, I will show you how to create a 3D model with our software solutions and automatically attach attributes to it. So in the latest release, we have significantly improved the functions related to BIM. So firstly, we changed the property set dialog box so that it can be now easily expanded, and property sets are now arranged in alphabetical order. Then we also redesigned the Draw 3D Model dialog box. So in the past, the user had the option to automatically attach only one set of attributes, but now they can attach more. And just like in the property set dialog box, the user also has the option to sort in alphabetical order here in the dialog, and the dialog box is more flexible than before. But the best part is that the performance has improved, so drawing the 3D model and adding attribute is now faster than in the previous version. Throughout the presentation, I will use a practical example of road reconstruction, and I will also show you what such a model looks like in Navisworks and in Vexel Manager. Following that, I will explain why the data attached to individual models in the drawing is so important for making construction and cost analysis. And additionally, I will present some other practical examples of BIM projects created with the Platea and Ferrovia programs. So overall, my goal for today's lecture is for each of you to take away as much practical information as possible. So I want you to learn something new during this presentation to expand your knowledge about BIM and to leave feeling inspired and motivated. I also hope to encourage you to start your own BIM projects. So BIM is the future of the construction industry, and with the knowledge you achieve, you can quickly gain the advantage over your competition. Okay, so let's take a quick look at how BIM came about and what it is. So imagine it's around 1985, and after a month of drawing plans with a pencil and a ruler, someone tells you to raise road profile by 10 centimeters. You know, since it's a big project, the erasers won't help, and you have to redraw most of the plans for the beginning. So not fun, right? Well, the founders of CGS Labs also didn't find this kind of work attractive, so they decided to start developing road designing software. So the team of developers aim to transfer the classic design concept from paper to computer using basic geometric elements like lines, arcs, and circles. Then 3D modeling began to develop, and today BIM is established as the most successful design approach. So building information modeling is an innovative 3D modeling process that includes, all important information about the entire life cycle of an object. This means that the design concept is not just based on the geometry of the models, but also on the information attached to the elements. So design concept with the BIM approach relies on shared digital model, making it easier for users from different fields to coordinate using additional tools. The benefit of such collaboration is seen in saving the time and resources throughout the entire life cycle of the object. So many issues that were once only discovered, at the construction site can now be identified at the beginning of the planning process. This can be done using different tools to detect clashes, and submodels showing each construction phase are also very helpful. By adding a time component, we get what's called a 4D BIM model, allowing the animation of the construction process and simplifying the path to the expected results. We can then add a cost component and other metadata important for managing and maintaining the object. So the final model also makes it easier to create visualizations. So building information modeling allows us to have all important information in one place, crucial for managing complex projects. This means that using the BIM process is essential in planning road or railway infrastructure, as many participants from different professionals need to constantly communicate and coordinate their project solutions. So BIM is, a very complex thing, and different experts look at it differently, depending on what they think is most important for them. So today I will introduce BIM to you through the eyes of a road or a railway designer, because I have the most experience in this field. So I had the opportunity to work on the currently largest Slovenia railway infrastructure project, the second railway track Divača-Koper, and in addition, at CGS Labs, we also offer BIM consulting for companies worldwide, allowing us to identify the common challenges that designers often face. Besides, we run the educational program for Building Smart Professional certification. So to begin a BIM project, it is essential to define project requirements. This is a crucial step for the successful implementation of BIM on an infrastructure project. The next significant step involves modeling and attaching attributes. Another important aspect is collaboration and coordination, which can be seen as a continuous process from the project start to its finish. It is also essential to understand how to create a 4D, so time-based, and 5D, cost-based simulations once you have a BIM model ready. And finally, delivering the project to the client is crucial. An important part of the BIM process is also maintenance and management. However, maintenance and management are more important for the designer to understand how to define project goals and project requirements better. And of course, this process may involve many other activities, but these are the most crucial ones we will be discussing today. Okay, to help you better visualize these steps, I will guide you through these key stages using a research BIM project as an example. So we created this BIM model for road reconstruction to test and then also to improve our BIM functionalities in Platea. Furthermore, in collaboration with Bexel Consulting, we took it a step further by developing 4D and 5D simulations. So we choose this project because it has many different infrastructure objects on a very short section. So this includes an existing tunnel, then new support structures and bus stops. Additionally, we modeled 3 intersections and also a roundabout, and each of these infrastructure elements was entirely modeled using Platea software. Okay, to kick off, let's delve into the foundation of our approach. So the ISO 19650 standard and workflows. So ISO 19650 is an international standard that provides guidelines for managing information models, in the construction industry. So this standard plays an important role in shaping how we approach the management of information throughout the life cycle of a project. In the diagram, the ISO 19650 workflow consists of 8 main steps. So assessment and need, invitation to tender, then tender response, appointment, mobilization, collaborative information production, information model delivery, and then project close out. The workflow begins with the appointing party or the client, appointing an information manager. This manager is responsible for creating a group of documents that summarize the project's exchange information requirements. So the exchange information requirements document then becomes an invitation to tender. Prospective lead appointed parties respond, by answering questions and completing a pre-appointment BIM execution plan. So we can also call it pre-BIM execution plan, and also a mobilization plan. The client reviews these responses and make an appointment for a lead appointed party. So this marks the completion of the appointment step. Once appointed, the lead appointed party begins the mobilization step, where they prepare to start work on the project. This involves setting up the necessary resources and systems to carry out the project efficiency. The next step is information production, where the lead appointed party, along with any other appointed parties, produce the necessary information for the project. So this information is structured according to the requirements set out in the exchange information requirements and the BIM execution plan. After the information has been produced, it is used in the information use step. This involves using the produced information to carry out the project, whether it's construction, renovation, or any other type of project. And finally, the workflow concludes with the project close out step. Here, the project is completed and all necessary documentation is finalized and handed over to the appointing party. This marks the end of the project and the ISO 19650 process. So as an important part of the process, we have discussed the BIM execution plan plays a key role for the designer. It's like a roadmap that helps the lead appointed party and others in creating project information. Now let's take a closer look at what the BIM execution plan is and how it guides the steps in producing and using project information. So the BIM execution plan is a document that assists projects participants in moving forward with well-defined roles and expectations. So it serves as a framework for strategically implementing BIM, utilizing consensus, build best practices, standards, and protocols. So the BIM execution plan is a very important component, especially for large or complex construction projects involving multiple collaborators. By outlining clear roles, responsibilities, and facilitating real-time communication, the BIM execution plan keeps everyone in science, ensuring that construction remains on track. The purpose of this document is to ensure the efficiency of project teams and the quality of the deliverables, which is crucial for project success and the adoption of BIM technologies during the construction, use, and maintain phases. So the most important elements in BIM execution plans typical are, general project information. So the document begins with the overview of the project, including information about the client, project name, location, project description, accepted outcomes, and the timeline for each project phase. Okay, then goals and areas of BIM implementation. Then project organizational structure. So this defines the roles and responsibilities of individuals in the BIM process. Often there is also an additional document with all participants and their roles. Then planning key BIM implementation processes. So these sections uses process diagrams to illustrate the critical processes for project development, typically organized into phases. For example, the first phase could be the development of the BIM execution plan. The second phase covers the preparation and approval of project design requirements. Then fourth phase involves the review of submitted documentation, and the fifth phase focuses on delivering the final project documentation to the client. Okay, then 5 is collaboration strategy for project participants. The BIM execution plan also defines which common data environment participants will use and how they will communicate with each other. So this includes details on how often meetings happen, and who will attend them, which project portal will be used, and how participants will exchange models. So in BIM projects, all documentation is typically stored in a selected portal. And in this section of BIM execution plan also outlines how files and models should be named. So, and when we collaborate on projects with others, we really don't want, something like this happen to us. So I know this is familiar for you, but let's say only on the desktop of your personal computer. So then the next thing that is that you can find in BIM execution plan is model element development planning. This section defines the level of development and level of information for the models. Then model guidelines. This includes information about sizes for partial models, units, also for measurements, language and coordination systems. Then final model delivery. So the BIM execution plan specifies how the final 3D BIM models will be delivered and in which software it will be created. Then quantity and assurance strategy for BIM implementation. So this part outlines the types of models quantity checks, who will perform collision checks, and what the report structure should be. Then selected information technology infrastructures. A table provides a list of the software used by each company in implementing BIM, then information delivery plan, and also some other attachments, for example, participant lists, attributes tables, file naming convention, and others. Okay, and after we have defined all these key elements and also selected the software, we can start modeling. So today we will look at how this works in our software solution. So the process of creating a 3D or BIM model is the same whether we use Platea or Ferrovia. So the biggest advantage of those two programs for BIM projects is that the BIM approach is very similar to classical design. Just like when we create 2D documentation, we first draw alignment profile, calculate super elevations, and draw cross sections. And when drawing cross sections, it is important that we have planimetric quantities for all the elements that we want to draw as a 3D solids, and then we can draw the 3D model with just one click. So those of you who are seeing our software solutions for the first time today maybe wonder, okay, what is this planimetric quantity? So essentially, it is a hedge that can be used to create a quantity takeoff report and draw a 3D model. So for example, the planimetric quantity representing humus, is marked in pink. This planimetric quantity is drawn, in the first cross section and then also in the second one. And Platea and Ferrovia draws the 3D model, by connecting the planimetric quantities between cross sections. The advantage of this approach is that it allows us to upgrade older 2D drawings to 3D models without having to start designing from scratch. Okay, so let's quickly look at how to make a model directly in the Platea. So in the drawing, I have made an alignment, profile, and cross sections with planimetric quantities. Okay, and to create a 3D model, I simply start the draw 3D model command. Okay, select the elements. I want to draw as a 3D model, and then I click. Okay, and after that, the software will draw a 3D model of the entire road. So you can see that the process, is very simple. Okay. But since we want to create a 3D, a BIM model, sorry, not a 3D, but a BIM model, we also need to attach property sets to these 3D solids. So in CGS Labs solutions, the user has two options, automatic attributes, which values are calculated and inserted automatically after drawing a model with the draw 3D model command, and attributes that are defined and attached manually. And in addition, it has a tool for viewing and editing attribute values. Okay, so let's take a look at this process of adding property sets. So first, we need to define property sets in the property manager. Okay, to add a new property set, we click on the plus button on the left and then define the name and press OK. Afterwards, we click on the plus button on the right to add attributes. We define the name, and then we select the property type. And here, if you choose the user-defined option, it means that you will have to enter the attribute values manually. So we enter the default value is cases where we know that it will be always the same. So if you choose one of the other option for property type, the program will then automatically insert the value of the attributes after we run the draw 3D model command. Okay, and what is here also important is that information about which attributes you needed to attach to an individual model can be found in the BIM Execution Plan. Okay, so this is, I think, the last attribute. So we write the name, select the property type, define the value, and then click OK. And once you define all the property sets, you can run the draw 3D model command. Then you define source data, alignment, select quantities, and then define the corresponding property set for each quantity. So for example, base course property set is for the element base. Okay, here, okay, select curve, and then I define those property set for each element. Okay, and I will also add the location property set and the project. No, because we can now add more than one property set on the 3D model. Okay, and now we can check if those attributes are attached to the models. You can check this by running the property set editor command. Okay, so I run it, and then I select one 3D solid in the drawing, and you will see that attributes are now attached to it. And you can notice that some attributes like volume, stationing, and axis were entered automatically. Okay, and during the project itself, a key advantage of BIM modeling is, of course, collaboration and coordination among various project stakeholders, including architects, engineers, and contractors working on different aspects of the construction project. One of the key components facilitating this collaboration is the common data environment. So this is a collaborative platform where project information and data are shared, managed, and maintained throughout the life cycle of a construction project. The most significant advantage of using a common data environment is absolutely that all stakeholders can access the latest project drawings and specifications. To help you visualize how this works in practice, there is an image on the slide that shows the shared data environment called Construction Cloud by Autodesk. This tool stores data in the cloud, allowing project stakeholders access to project documentation from anywhere with internet connection. So furthermore, enabling everyone involved to access the latest model opens the door to early detection of errors and conflicts. So this, of course, reduces the need for costlier corrections that might only be discovered during the construction process itself, offering a twofold benefit, saving time and also resources. And BIM projects not only streamline decision making with their extensive database, including material specification, cost estimates, the maintenance schedules, but also significantly simplify construction execution. Contractors can carefully plan construction procedures, including the entire logistics, ensuring that the actual construction closely aligns with the project's initial plans. This eliminates unexpected surprises on the construction site and reduces the likelihood of errors and the need for expensive corrections. And as a result, BIM brings us greater efficiency and reliability to the construction industry. And one of the very important aspects of modeling is clash detection. It is the process of identifying and resolving clashes or conflicts with the BIM model. These clashes occur when different elements such as structural components or mechanical systems interact or overlap in a way that is physically impossible or problematic in the real-world construction. So detecting these clashes early in the design phase is crucial, as it helps to prevent costly errors and rework during the construction phase. It allows the project team to address and resolve this issue proactively, leading to smoother construction processes, reduces delays, and ultimately significant cost saving. In the beginning, clash detection involved the BIM manager taking screenshots of every issue in the design and creating a PDF report to send to the project team. However, of course, this process had its limitations. It often took a while for other designers to locate the issue in the model, especially in complex models with a lot of similar elements. It's hard to keeping track of a response, and also the keeping track of responses was very challenging. Then fortunately, these issues have been solved by the BIM collaboration format standard. It offers a straightforward and transparent way to share clash reports and comments among all project participants. Each problem is assigned, with a unique ID, making it easy to monitor the number of open issues, responsible parties, and deadlines for resolutions. This means that users no longer need to spend, time hunting for issues within the model, because the BIM collaboration format, they can instantly pinpoint their location. Okay, so let's take a look at a short video from Building Smart that nicely shows what BIM collaboration format is.
Delivering BIM helps save time and money on a project. But when managing design coordination with inefficient PDFs or spreadsheets, these savings can be lost. 3D model authors have to manually locate design issues using only descriptions or screenshots. The process is slow, confusing, and error-prone. But there is a better way, using OpenBIM, a vendor-neutral approach to collaborative design, construction, and operation. The BIM Collaboration Format, or BCF, is the open BIM format for design issues. Information can be exchanged and used with any BIM tool, making resolution faster and more accurate. Let's take a look. The BIM Coordinator can federate models in an analysis tool like Solibri Model Checker and create an issue report. These issues can be made available in a common data environment like Aconex. All the data has come across from Solibri Model Checker and can now be used by other team members. The BIM Coordinator can select those issues relevant to the mechanical engineer and assign them for resolution. The mechanical engineer opens the issues in an authoring tool like DDS CAD. Again, the data has come across from Solibri Model Checker and Aconex, including a viewpoint link that takes the engineer straight to the issue in the 3D design. He fixes this issue, adds a comment, and marks it as fixed to indicate resolution. Using tools like BIM, he can continue to monitor issue progress over time to keep the project on track. Job done, and it's only lunchtime. Open BIM formats like BCF are already being used across the industry today. Getting started is easy. To find out how, go to buildingsmart.org.
Just a second that I open my presentation again. Okay. And when we have fully designed model, with attributes, we can use it to create different 4D and 5D simulations. This brings important improvements to BIM projects. So the 4D simulation includes a time component, allowing us to see and manage the progress of construction activities over time. This helps us understand the project better, optimize processes, and keep a close eye on progress so we can act promptly when needed. On the other hand, 5D simulations combine time with cost analysis. This helps us estimate the costs of the construction elements, monitor the budget in real time, manage risk, and integrate with schedules. Together, these simulations significantly boost efficiency and control over the project, ensuring it stays within budget and meets deadlines, and they contribute to better outcomes in infrastructure projects. But here is the thing. So we don't create 4D and 5D simulations in design software. We use project management and planning optimizing tools like Navisworks or Bexel Manager. To open models that we created in programs like Platea or Civil 3D in these tools, we need to export them to IFC. So at this point, I will run a quick survey that will appear on your display. So my question is, have you ever used IFC file format for exchanging the models you designed? Okay, so the survey should appear on your screen. Okay, now you can see it. Mm-hmm. Okay, thank you for your answers. So I see that few of you are unsure about what IFC means, so let me quickly explain. So IFC is a standardized digital description of the build assess industry. So to make it simpler, I think of this way. So imagine you have a mechanical engineer who creates mechanical installations on one side and then architect on the other side. So before IFC existed, the workflow looked like this. So the mechanical engineer made plans and sent them to the architect in a PDF format. Then the architect had to open these plans and recreate them in their own model, so in their own software solution. This process led to extra work, time wasted, and of course higher costs, not to mention the possibility of mistakes. But today, if a mechanical engineer works in a program like SolidWorks, for example, and exports their model to IFC, the architect can easily open it in ArchiCAD program. So IFC is basically an open format for for exchanging data. And I would like to mention one more thing here. So exporting models to IFC often happens earlier, specifically during the coordination step. For example, if we are using different software solutions and we want to open a model that mechanical engineer created in a SolidWorks, in a program like Civil 3D, they can easily send it us in the IFC format. Okay, so let's go back to our example. So we have now, for example, exported models from Platea to IFC format and opened them in the Excel manager. And since we have a BIM model, which means we have information or attributes attached to the elements, we can link this to the bill of quantities and create 4D and 5D simulations. So in the previous step, we exported the model from Platea to the IFC, and we open it to the Excel Manager program. And as I mentioned earlier, Excel Manager is designed for project management, and we can create 4D and 5D simulations in it. And if we look at this picture, we can see a model in the middle, and below there is a bill of quantities. Okay, the link between individual models in the the link between individual model elements and the bill of quantities in the element query column, which is marked in blue. So for example, for the item construction of AC8 surface layer in the model, we select all the elements of the type surface layer, material asphalt, and type AC8 surf to calculate the area. Because each component also has information about the face, we can then also create a 4D simulation, and if we add costs, we can even have a 5D simulation. Okay, so the final result of the is this construction animation. You can see the progress of the construction, and the costs are displaying at the top. Of course, this example could be optimized because currently the construction is shown only by stations, and it would make more sense if, for instance, all approaches to the roundabout were built at the same time. Okay, project delivery is then a key step in the BIM process, so which means completing our work and delivering all the information to the client. So this step is essential as it allows the transfer for all the data we have collected and proceed during the design phase to the phases of construction, use, and maintenance of the building. When we talk about project delivery, we need to pay attention to some key aspects. So the first one is the format and structure of the documentation. As designers, we need to ensure that all documentation is delivered in line with the client's requirements. So we said that these requirements are usually defined in the project brief in BIM Execution Plan. So this includes file format, file and model naming, folder organization, attribute table, delivering and quantity control reports, review reports, and statements. So then the second aspect is the method of delivery of documentation. So deliver documentation to the client, we need to use a common data environment. And the third aspect is the verification of completeness and compliance of documentation. So the client must verify that the received documentation is complete, consistent, and of high quality. This can be done with the help of programs for reviewing BIM models such as BIM Collab, which allow visualizations, commenting and marking of models. The client must also verify that all requirements from the project brief and BIM execution plan are met. And if any deficiencies or errors are found, the client must request the correction by the designer. So this step also means the beginning of a new phase for the building, so the phase of construction, use and maintains. We can say that the management and maintenance is crucial final step in a BIM project. After the construction of the BIM of the building, the BIM model enables efficient planning for maintenance tasks, performance monitoring, upgrades and renovation planning, as well as improved energy efficiency. This ensured long-term success and the preservation of the building's value. So in today's lecture, you have already learned quite a bit. So we introduced the BIM concept and gone through the key steps to see what a designer needs to pay attention to in a BIM project. So to recap, it all starts with defining the project requirements and goals. We also mentioned that the importance of the BIM execution plan document for successful BIM project. Then next we looked at creating BIM using CGS Lab software solutions. And another important step in the BIM process is coordination and cooperation, where we also learned about the concept of common data environment, which allows all stakeholders to access the latest project drawings and specifications from anywhere, anytime. Okay, and once we have a detailed model with attributes, we can perform various simulations and analysis, and the final step carried out by road or RAID designers is project delivery. And when the project is completed, the BIM model is handed over the management and maintains. The project I showed you today is not the only one we are working on. So in the last year, we completed 3 research projects, 3 BIM research projects, but this year we are currently involved in active project in Slovenia and the Czech Republic. And the majority of these projects are road reconstructions. So for example, this is the second demo project where we focus more on modeling a double track railway with Ferrovia, and we also modeled power lines with PowerPad. So PowerPad is a software solution that assists in the design of both new and existing power lines, and it is the first and the only power line design software solution in the world with the support for BIM. Then in this picture, you can see an example of an actual project. It involves the reconstruction of approximately 5 kilometer long road in the Czech Republic at the detailed design level. And here is another example from Panama, where we created a model for reconstruction of roads of the entire settlement. It is interesting that this and the previous case, the 2D documentation was created in the Civil 3D, and the BIM model was entirely made in Platea software. So these projects also serves as a basis for developing new features that aim to make your complex and time-consuming work easier. At this point, I would also like you to invite you to watch our tutorials on our YouTube channel and follow our LinkedIn profile, where we post updates about our software solutions. I hope you have learned something new in today's presentation and that you will be motivated to start working on a BIM projects. So, and if you find it challenging along the way, remember Einstein's wonderful thought that in the middle of every difficulty lies opportunity. So thank you for your attention, and I wish you a fantastic day ahead. And with that, I pass the virtual microphone back to the Gregor.
Finally, we have reached the end, and we have a couple of questions for the audience.
Sorry, I just need to find the questions. Okay, here is one question. Would all the project participants need to use the same software to detect collisions? No, okay, it depends. So if you want to detect collisions only just for your models, okay, you can use your software solution. Of course, you can also in this usually in these software solutions you can import IFC formats, so others can send to you IFC models, and then you can use your own software solution to detect collisions. For example, Navisworks, or I think you can also detect collisions in Excel Manager. And then, for example, in our software solutions, you don't even need to export models to IFC, but you can do this within the Platea or Ferrovia. Okay, then the next question is, just a second. Do you have any solution to design utilities as part of the road or railway beam design? I'm not sure which utilities. Gregor, do you understand? Do you know what it means with this question?
No, I'm trying to figure it out myself.
Yeah.
If you can maybe send us an email a bit more descriptive, then we can even answer by email.
Okay, then one question is, where are the definitions for the attribute saved? Only in a file? Okay, I'm not sure about this question too, because it could be, okay, at the beginning, those information about the attributes are usually in Excel table that are attached to BIM Execution Plan. Okay, but then when you are working on in a software solution, it's based on the program. So for example, here in Platea or Ferrovia, you can check those if those attributes are attached to the solid by using our commands, and then when they are exported, they are also written in the IFC. And for example, if you open this this IFC in Navisworks or in any other software solutions, then you can also check those attributes. Okay, we also have many other questions. I'm not sure if we will take time to answer also. Maybe Gregor, we can answer other question by email.
Yeah, there are really many. So
yeah.
I suggest you prepare the answers and the mail as a follow-up. And as we mentioned in the beginning, we recorded the webinar, so you will also get the recording, and maybe you can share it with your colleagues that weren't able to attend today. Maybe I would just share my screen for yeah, I have one more slide, and I would like to guide you again to our section where we feature all the webinars for civil engineers. There are quite many that we did in the last couple of years that are still very interesting. And also today's webinar.
Gregor, sorry, they can't hear you. But
okay, just a second. Yeah,
Okay. Okay. Sorry, some of you can't hear the Gregor, so I will continue the presentation. Yeah. So you can also find our previous webinars on our GoToStage platform. You can find it on our website, and all the previous webinars are available and they are free. Okay, maybe the next slide, Gregor.
Okay, I found the glitch. Now it should be fine. Okay. So actually, this is what we have prepared. I think that Peter already mentioned the other channels, so I can invite you to visit our webpage where we have lots of information. And of course, any questions that you might have regarding our solutions or regarding what you have seen today, you're most kindly invited to send us an email or even call us, and we'll be gladly to get in contact with you. So thank you very much for today, and
Yeah.
hope to see you soon on one of our next webinars.
Okay, yeah. Thank you very much for your attention. Bye.
Bye-bye.